Hello, my name is Beth Dixon, and I am the Math Lab Coordinator in Working Room 222 of the Math and Behavioral Social Science Building. It is my job to help students through their math courses here at Walter State. And today I'm going to do a lesson on the standard normal curve, and that is learning how to read the table in the back of your book where the mean is 0 and the standard deviation is 1. So basically, it's where we're given a z-score and asked to look it up, and we're asked to find the area. And in this case, we can find three types. We do three basic types of problems. We do an area where the area is less than a z-score. We find areas greater than a z-score, or we find areas between z-scores. Those are the three basic types that we do. We're going to start with our first problem here that you see, and it says find the probability that z is less than 1.37. And again, remember for all of these problems in our normal curve that our mean is 0, and our standard deviation is 1. So we do not have to do anything else to the problem because anything that we're given is already as a z-score. It's the standard normal where the mean is 0 and our standard deviation is 1. So what we want to do is find the area where z is equal to 1.37. So each of these tick marks are representative of our z-scores. So that would be a z of 0. That would be 1. So 1.37 is going to be approximately here. Now, if we were drawing these without tick marks, I would draw these freehand, and we wouldn't have to be drawn to scale as much. But since this is taped and we want to be a little accurate, I've used a nice graph so that I didn't have to draw these, and they'll be a little bit more accurate. But they don't have to be completely accurate. So I'm going to draw a positive 1.37. And since it's less than, I'm going to shade to the left. And there's a little trick I can remember. If it's pointing to the left, I'm going to shade to the left. Now, a picture is worth 1,000 words. So we always want to draw our pictures to go with these. And once I've shaded, I want to see then that I'm finding the area to the left. Then I'm going to take my chart. And as we're in transition of books, the chart I may be using now may be different than the chart you're using. And then once we've transitioned into the new book, you'll say, what is she talking about? This does look exactly like the chart I'm using. But if it's not, it's the same principle to use the chart. We're going to look at your chart. Notice the picture at the top of your chart is shaded to the left. That's the same regardless of the chart you're using. That tells you that the chart is giving you the area to the left. Always check your chart that you're using. It gives you that kind of information. Notice that the chart gives you the Z. That tells you you're looking up a Z. If you're using the charts that we're using in the spring of 2010 are divided up into two sections, a negative and a positive. Since we're looking up a positive, you go to the positive. After the spring 2010, we'll be using a chart that has both of those scores in it. So I'm going to come down here, and I'm going to look, try to do this where it makes sense. And I'm going to look up 1.3. And then I'm going to come down the 7 column. You can't see my finger, but it's going to come into focus as we come down. And that's the 7 column. And as I come down that, you'll see that it crosses, and there is the number. That is the area where it crosses. And I get the number 0.9147. I'm simply going to take an arrow and use that arrow there so you can see where that crosses. That's the 7 column at the top of the page. 7 column at the top of the page, and I just come straight down, and where that crosses with the 1.3, and notice especially on this new chart, it's very tiny. So you want to be able to use a straight edge. Notice my nice little straight edge here to help me find it, and I pick up that number 0.9147. Now what does that number tell me? Again, because the chart tells me that it's the area shaded to the left. So what that tells me is it's this area right here is 0.9147. So since that area is the shaded part in the area I'm looking for, the probability that Z is less than 1.37 is 0.9147, and that is my answer. And to make sure that the teacher knows what you're looking for, put it in a box, circle it, put it in the answer blank that your teacher leaves, so somehow indicate that that is your final answer. Let's do one more of those for practice. Again, another less than. In this case, my number is 0.024. Again, remember that 0 is in your center. That is where, in our case, because we're doing the standard normal, the mean is 0 and the standard deviation is 1. And since 0.24, since it's negative, it's going to go on the negative side, but will be just slightly below. We'll draw a line here. And shade in the area to the left because it is less than. Notice whether it's less than or equal to doesn't matter. We'll still shade the area to the left. And it is negative 0.24. Again, taking our chart, the first number was 0.24. When we looked up 1.3, we looked over here at 1.3 and then over to the 7. At 0.2, we'll look up negative 0.2, and then we'll go to the 4 column, which will be the 4 column, the last digit here, and then that gives me the negative 0.24. And gives me 0.052, 0.4052. And again, that's going to be the area to the left. You see how I marked that on my problem? And yes, the chart is cumbersome to use because I'm not taking it out of the book, but you just pull it out and you can use it, 0.052, and that's this area, which is the area I'm shading. And then that gives me that the area is 0.4052. The other thing, as you do this, notice that these answers are reasonable. This area is a little less than half the chart. Half the chart area would be right here at 0. This is less than half, and I've shaded less than half the area. This one I shaded way more than half the area, and I got way more than half the area for my answer. So the answers were reasonable. Both of these were less than. And for me, the way that I remember it is for less than, it's shaded to the left, and we leave the table as the answer. Less, left, leave. It's a nice little alliteration there. Okay, let's look at the next examples. And let's look at some two greater than examples. For our greater than, we're going to be looking first for the area or the probability that the z is greater than or equal to 2.05. Notice that I'm changing up sometimes the way it's listed and worded, because you'll see all different kinds of notation as you do it, but it all means the same thing. And again, every time in this case, our mean is 0 and our standard deviation is 1, because we're dealing with the standard normal. Now, as we look here, that gives us a z of 0 here, and we want to know whether z is greater than or equal to 2.05. There's our 2. 0.05 would be here, and we're talking about greater than that 2.05. And so it would shade all the way out here. So it's going to be a very small area. Okay, now, when we do 2.05, again, we'll take our chart. .0 are the first two numbers. So I come down to 2.0. You cannot see that, sorry. 2.0 here. And then I need to go to the fifth column, which you can't see, but I'm bringing down my finger down to 2.05. And I get 0.9798. That's a very large number. And I said my number would be small. Why is that? Well, I'm going to write that in, 9798. 9798. Well, look where I wrote that number. Remember from my table that it's the area to the left that I'm looking up. So it's actually this area to the left here that I found. I need this little area to the right. How can we find this? And of course I know, but I'm trying to give you a second to think about it as you look at this. Because this area under the normal curve, it represents all of the possible areas, its total area, just like in uniform distributions, just like in probability distributions, represents all the possible areas, and all the possible areas and all the possible probabilities always add up to be 1. So it's that powerful complement rule that's our most powerful tool. And the fact that the complement rule says that all the probabilities add up to be 1, if we go 1 minus 0.9798, we'll get what's left over here that's shaded. So we simply will take our calculator, 1 minus 0.9798, and we'll get 0.0202. And that'll be the part that's here. So the probability that z is greater than 2.05 is 0.0202. Left out a 0 there. And that'll be our final answer. And again, that's why you want to block out your answers, because you'll have some other numbers here. So when it's greater than, we're going to use the complement, because we'll find the area to the left, but we want the area to the right, the rest of the area. So to get it, we'll subtract from 1. So let's try that if the number is less than 0, if it's a negative number. So in this case, let's look at it if it's negative 1.98. Okay, negative 1.9 would be the first digit. So we'll come up here to negative 1.9 and then 8. So we'll come to the 8 column. And again, I'm just using the 8 column here. And over to the 8 column. Negative 1.8. Now, I didn't graph it first. Oh no. So that means I need to graph it. Now sometimes I'll do that. We all do that as we do it. We get in a hurry. But that's why we want to graph it, because I'm not sure what to do with that area. Okay, negative 1, negative 2. So negative 1.98 is going to be really close down here. And I want the area greater than this. So I want all of this area here. And what I looked up, because I didn't move it, I can find it again coming down the 8 column on that negative 1.9 row, I get 0.0239. And again, that's the area to the left, 0.0239. I'm going to triple check that because I'm on tape and don't want to miss it because of an eye issue. I don't want this area to the left. I want the area to the right. So to find the right, I'm going to go 1 minus 0.0239. Take the calculator out. 1 minus 0.0239. And that gives me 0.9761. 0.9761. And that gives me the area, the probability that Z is greater than negative 1.98. And so for the greater than, we're going to shade to the right. And we're going to go 1 minus the table to get the answer. And remember that these videos do pause, and so that you can pause and replay these to take these notes. Also remember that if you would like these handouts that I'm using, you can come by the Math Lab and I'll be glad to give you a printout of these handouts. Or email me and I will be glad to send you an email copy. Okay, let's look at the third option, which is the between. Now, find the probability that Z is between negative 1.02 and 2.12. Now, that's really what this says. It technically says that negative 1.02 is less than Z, less than 2.12. But we really look in math that this statement says that Z is between these two numbers. So this time I'm going to remember to graph it first. And so again, the mean is 0 and the standard deviation is 1. I cannot emphasize that too much because when we get to the next section, that won't always be the case, and we'll have a step to do before we get to this step. So we want to remember that in this case, that information is given and that these are z-scores, and this is a standard normal distribution. Negative 1.02 is going to be slightly below that negative 1, and it's going to be here. The z at 2.12 is going to be here, and we want to find the area between those two scores. Now I'm hoping that this shows up with some color that I'm going to use, so bear with me if it doesn't. We'll do the best we can. But here's what we're going to do. We're going to first look up the larger number at 2.12. And it doesn't matter whether both of these are negatives or both of these are positive or one of each. The process will be the same. We'll look up one number at a time, and I'm going to look up the 212. 2.1, the first two digits, 2.1, and then 2, and that gives me 9830. 2.1 and then down the column to be 9830. Well, we want to see what area that really is. Remember that this gives me, I can't emphasize it enough, the area to the left. Well, what that really gives me is this area all the way back this way as 0.9830. That is technically too much area. It's more than the red area. It starts out and does really good, but it adds this tail down here that we don't want. So this is not the number that we need. So now let's look up negative 1.02, the second value, negative 1.02, which is this tick mark, this line right here. So we're going to look up negative 1.02. Come over to the table, negative 1.0, then the 2. We get 15, and I went down the 2 column, negative 1.02 down the 2 column, and got 1539. Now, this is going to give me now I'm going to cover right 1539 right up, but I'm going to mark it out in this pencil here. It gave me that little bitty tail there. Well, I don't want any of that tail. So the 9830 gave me from here all the way back. This 1539 gave me just the tail. But I still want just the red area. So how am I going to get the red area? Well, I'm going to subtract. 9830 minus the 1539, that's the tail, will leave me just the red area. Because the 9830 is all of it back, the 1539 is just the tail. If I subtract out that tail, I'm going to be left with the red area. So again, taking the calculator, 0.9830 minus 0.1539, and I get 8291. So the probability that D lies between those two values is 8291. And just to show you that it works the same, if both numbers are positive, let's quickly go through this example. The probability that is between 1.76, 1.7, and then go down the 6th column. And again, just take my word for it that I'm coming down the 6th column, and I get 9608, and that's the 1.76. There's 0. 1.76 would be about here, and so that's going to be 9608 from here back, and 2.25 is going to be here, so we're just looking for this little area right there. And looking up then 2.25, 2.2, And then coming down the 5 column gives me 98, 78, 98, 78, which would be from this mark all the way back. So I want to take 0.9878 minus 0.9608. So the answer is 0.27, 0.027. And so when we're finding the area between two values, we shade between, and the answer equals table minus table. And I'm going to pause and let that be part 1 of this lesson on the standard normal curve.